All right, we'll go ahead and get started. First, I want to say good morning and Happy New Year, and welcome everyone to the January California-Nevada Drought Early Warning System Drought and Climate Outlook Webinar. Thank you for those that have joined us previously and those who may be joining us for the first time. My name is Amanda Sheffield, and I am the Regional Drought Information Coordinator for NIDIS in California, Nevada. We host these webinars in partnership with the California Nevada Applications Program, who is a NOAA RESA team. This series is designed to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events. Before we get started, please note that this webinar is being recorded, and the recording and a brief summary will be available on drought.gov and on the NIDIS YouTube channel later this week. This month, we're providing a winter status update, definitely looking in to see how we are doing after the rain and snow and then the lack of in the last few weeks and see how we're doing. We've got a great set of speakers covering that, as well as the California and Nevada state climatologists are joining us to provide their perspective at the end about what's going on with the current drought. The speakers will be more introduced fully later on, but I will pop their information after I give my little presentation here in the chat box. So you have more information on them and their websites and things like that. Quickly before we get started, I just want to talk a little bit about NIDIS for those who may not be familiar with us. Our mission is to improve the nation's capacity to proactively manage drought-related risks. So we do this by helping provide the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. We do this through a lot of activities, including our drought early warning systems, which California and Nevada are one of them, and a lot of activities under drought prediction and forecasting, supporting drought planning and preparedness, strengthening collaboration, supporting drought impact assessments, and of course, hosting and developing the U.S. Drought Portal, which is drought.gov. Just a little bit more about our early warning systems. As I said, California, Nevada is one of them, and so that's where we hone in our activities to work with our new and existing partner networks to optimize that information, to make sure everyone has what they need to have readily available, easily understandable, and usable data for decision making. We hope through the drought early warning systems and the activities we do there, such as webinars about like this, that we can better monitor, forecast, plan for, and cope with the impacts of drought. And just quick, I mentioned this on the last webinar, but in case folks weren't on there before, obviously drought.gov is a great resource we hope you would use for finding drought information, conditions, forecasts, etc. at the national, state, local, watershed level. But we also recently updated our Drought Outlook email alerts. So previously you could sign up on our webpage for drought condition alerts, but we recently added the official operational National Weather Service Drought Outlook email alerts as well there too. So anytime drought changes in your area or a drought outlook is released, you can get an email. You can find this at the website on the page or just go to the bottom of the homepage on drought.gov. And with that, we'll go ahead and get started. If you have questions as we go through our presentations, please put them in the question box in the GoToWebinar panel. We'll get to most of the questions towards the end, but we might do a few quick ones in between speakers. Today, we have first the Drought and Climate Update, which will be provided by Dan McAvoy. He is an assistant research professor in climatology at the Desert Research Institute. After Dan, the Outlook will be provided by Mike DeFlorio, who is a seasonal researcher at CW3E at Scripps Institution of Oceanography. And then finally, at the end, we'll get some state climatologist perspective on the current drought from Steph McAfee, who is a University of Nevada, Reno associate professor and the Nevada state climatologist, and then Mike Anderson, who is the California state climatologist at California DWR. And so with that, Dan, I will pass control over to you, and we can go ahead and get started.
Right. Okay, thank you, Amanda, for the introduction and for having me here today. Get this in full screen and get started here. All right, so yeah, thanks again, Amanda. Happy to be here today and share the latest update on our drought and winter climate and weather conditions. This is a recent photo from Heavenly Ski Resort a couple weeks ago, and despite the long dry spell, there is still snow in the mountains. Skiing's been not too bad considering, but I'll talk some more about that as we go. So What if I had a theme of my presentation today would be, despite some bursts of really heavy precipitation and snowfall this water year, we are still in a drought for our region. And so what I'm showing here are two maps from the United States Drought Monitor. The one on the left is from the end of September, September 28th, and then the one on the right is the most recent one from January 18th. And the one on the left has quite a bit more dark reds. That would be D3 and D4, extreme and exceptional drought. After 2 years in a row of drought and a very hot summer, we sort of reached the peak perhaps of this drought last summer into autumn. And then we did have some good storms in October and December that have helped to ameliorate some of those drought conditions, but we are still in a drought, and I'll talk about why that is. We still have quite a bit of moderate and severe drought in California and some patches of extreme and exceptional drought into Nevada as well. So then, if we had these big storms in October and December, why are we still in a drought after this wet start to the water year for some places? And so this graph here is a time series. This is statewide averaged precipitation over the entire state of California for each water year from 1896 through 2021. The values are hard to see, I apologize for that, but you can see the variability of the bars from extreme wet to extreme dry in some years. But if we look at these last 2 years, 2021 was the second driest on record, and 2020 was also very dry, well below average. And so once you get into these multi-year droughts, 2+ years, the impacts accumulate, the precipitation deficits accumulate, and it gets much harder to get out of that drought. And these are from the WRCC state climate trackers. So this is now the same exact figure, but this is for Nevada statewide average precipitation. And it looks a little bit different, but you know, the last 2 years are very similar. 2021 was also the second driest water year on record, and 2020 was not far behind that. So again, we're in this multi-year drought. It's going to be harder to completely get rid of the drought conditions in the region. And so if we continue one more slide looking backwards to last summer into autumn, we were at a pretty bad spot in terms of water supply and drought impacts. This graph on the left is the most recent reservoir conditions from the major California reservoirs. And most of the larger reservoirs are still below average. Lake Oroville is now at 80% of the historical average. But these reservoirs were at near or below historical lows this summer. Lake Oroville stopped producing hydroelectric power for a while due to the level of the reservoir. Lake Mead, which really is on the Colorado River water supply system, hit its record low this summer and went to the stage 1 shortage. And we had an extremely hot summer, record warm for many areas throughout the region. And so I just want to reemphasize that we're into the 3rd year of a drought, and it's going to take a well above average year to get rid of these drought conditions completely and refill these reservoirs. So now let's move on to what we've been seeing this year so far, and it's mostly good news. This map here is the total precipitation for the water year, October 1st through January 18th, and this is the percent of average precipitation. The greens, whites and greens are above average, browns are below average, and so there is quite a bit of greens on this map, and so most of the region has seen above normal precipitation to start the water year, the exception being parts of Southern California and Southern Nevada, a little bit along the California-Oregon border in Northwest California. And this largely, mainly came from just a few storms, one very large storm system in October, and then a couple weeks of solid storms in the second half of December. And so again, yeah, this was a boom or bust water year so far for California and Nevada. What I'm showing here to highlight this is data from the Northern Sierra 8-station index, which are some eight key long-term precipitation gauges throughout the Northern Sierra Nevada region, which are shown on the map there up in the left. and this shows the water year precipitation accumulation. This year is in blue here, dark blue, and then the teal blue is the historical average value. And you see we had this very large, very potent atmospheric river in October that brought close to 15 inches of precipitation for this 8-station index. We had a very dry, and it got pretty warm in November, dry spell, and then the winter started slow, and then boom, the second half of December got very wet again. And so we've remained above average, and from the 21st was when I pulled this data, we were at 129% of average. But these short, intense bursts is what we've seen. And then on the right is a graph from the state climate trackers showing sort of the variability over the past 12 months with respect to historical percentiles. And we see this year we've just gone, October was well above the 90th percentile, and then November was, very, very dry, and then boom again. So we've had this whiplash from wet to dry so far this water year. I wanted to throw a couple of other years on this graph to show some comparisons. First, the 2021 is highlighted here, which was again the second driest year on record for the state. And so we've already surpassed last year's precipitation totals, so that's a good thing. And then we have 2017, which was the wettest year on record, and we were sort of keeping pace with that for a little while, but then we've had this very significant dry spell so far in January. But the two other years I really wanted to highlight where we're kind of on a similar trajectory through early January was 2013 and 2011. And so in 2011 we had about a 6-week dry spell after a very wet start to the year, and then mid-February things really picked back up, and it became ended up being a very wet year with a huge snowpack by late March in the Sierra. 2013 was the opposite, where we had a long dry spell in January, and it never really picked back up. We got a few storms, but still ended up well below average. So, which way are we going to go here? We're at a similar trajectory, and we could really go either way at this point with a couple of months of the wet season still to go. So that was precipitation, and with those big storms in December, we had a ton of snowfall in the Sierra. The Central Sierra Snow Lab on Donner Pass, they broke a record going back to 1950 for the most snowfall, or I'm sorry, 1970, a 50-year record for the most snowfall in the month of December, 214 inches. That all came in about 2 weeks, so it was very impressive. Great to see all that snow in the Sierra. So if we look at the most recent snowpack values from the SnowTel and also the California, the CDEC snow pillows throughout the Sierra. This is the percent of median snow water equivalent for the end of the day on January 20th. And so if we look at the Sierra, it's mostly greens and blues, but we do see a few dots that have fallen below average due to these dry conditions. Still below average snowpack in a lot of the northwestern California mountains, as well as in northeast Nevada. The Ruby Mountains are slightly below average now. So what does this look like through time to kind of see how these wet and dry spells have played out in the snowpack? This is for the Lake Tahoe Basin. So all the SnowTel stations within the Lake Tahoe Basin in the northern Sierra Nevada. And so the black trace is the snow water equivalent for this year. This green trace is the long-term median, and then we have the extremes and the percentiles and the shadings. And so it started off very slow, very little snow through early December, and then boom, we got well above average, and it's just really dried out. Basically no snow accumulation since the new year. And so again, have we seen anything like this in the past? And I'm going to highlight again these 2 years of 2013 and 2011. Because it was very interesting how similar we were in terms of late December snowpack, and now are we going to continue to dry out like 2013, where there's essentially hardly any more snow accumulation in the Lake Tahoe Basin that year, or are we going to pick back up and wind up with more snowfall, which we saw in 2011. And one more plot now. So this is showing projections of the snow water equivalent based on the historical data. And so you basically, these plots show where you're starting now. So this has the black trace from this year. And you can see these different plumes going out from that. And what this is looking at is historically going back about 40 years or so, all the changes in snow water equivalent each day of the year. And so, you know, this red line is the minimum, the minimum change in snow water equivalent. And then the top purple line is the maximum. Then you have ranges of percentiles. So you can have, and this doesn't account for, you know, this is not a weather forecast. This is not a projection in that sense, but just based on the historical conditions, how much the snow water equivalent could potentially change. And we see the minimum and the 10th percentile lines here in red do get us to a below average snowpack, which could happen. But then if you look at the 50th percentile changes in snow water equivalent, that keeps us at or slightly above average. But this doesn't happen on a daily basis, and it all depends on the weather conditions. But this is just some sense of the trajectories that our snowpack could go in the Lake Tahoe Basin, given a variety of conditions. And so again, how is the snowpack holding up? Well, this is from a couple pictures I took from Mount Rose Ski Resort yesterday. And so, you know, it's holding up pretty well at high elevations. You don't get a lot of melt even during these dry periods in the north, the northeast, and the northwest aspects. So this image on the left is kind of northeast facing, and then as you go right, it's more east and then southeast facing. And you can see this snowpack's holding up pretty good. But there is quite a bit of melt going on, even at the high elevations on south-facing slopes. And so there, we are losing some of the snowpack on those direct south-facing slopes, even at 9,000–10,000 feet of elevation. And another thing I wanted to touch on is the land surface conditions and what that might mean for getting out or improving our drought as we go into spring and summer. So this is the gray-spaced soil moisture percentiles. This is the root zone soil moisture. These are compared to 1948 to 2012 for the range of percentiles. And you see in California and Nevada, this was from the end of September, extremely dry soil conditions before we got that big atmospheric river, lots of areas there below the second percentile. And then we got the big atmospheric river in October, and that completely went from near record low to near record high soil moisture based on this product for a big area in northern central California and northwest Nevada. Again, southern Nevada and California did not really get impacted by that event all that much. And then this was the latest map from January 10th, and we can see in that same area in the northern and northwest parts of our region, there's been drying already, and we're starting to get back to near average soil moisture for the region. And so it was very critical to get that soil moistened up in the fall before the snow fell in the mountains. And this is kind of emphasizing that point. This is again for the Lake Tahoe Basin, but now the soil moisture, the percent saturation from the start of the water year. And we see the black line is this year, and the green line there is the median going back to 2004. And so the atmospheric river, brought, at least for this area, near record soil moisture by the end of October. And then we dried out in November, but it's still well above normal. And so the key thing here is that the soils got wet before the snowpack fell, which is going to be huge in terms of when we get to the spring and summer for improved runoff efficiency, unlike what we saw last year. And so it's hard to see here because it's near the record low here, but 2021 is shown here, again, near record low soil moisture all year, and that led to extremely low runoff. I also highlighted 2013, which started off wet and then went dry, but because there was still snowpack on the ground, the soil moisture still managed to be okay throughout the year and didn't get too low throughout the year. So we do have hope for the mountain soil moisture under the snowpack to remain in good shape as we go into the spring. And I think very quickly, I just wanted to touch on a couple more things related to conditions of vegetation in parts of California. Green up in the foothills and non-snow covered areas in parts of central and northern California can happen beginning around this time. And so on the left, we have the veg dry, which is a index that considers satellite data as well as precipitation and other things to tell you about the condition of the vegetation. And we see some greenness, so unusually moist or green conditions for parts of Central California. And then on the right, we have the NDVI anomaly, which is also a reflection of how green things are, which doesn't tell you much in snow-covered areas, those deep, deep red colors. But in the foothills of the Sierra and parts of, around the Bay Area, things are greener than average. And actually, I pulled out a grid point from in the hills northeast of the Bay Area. And this is showing the green up for the past 3 years, which usually peaks in this area in March or April. And we're already higher. It's greener in that area than it has been at all for the last 2 years. So that's good as long as we continue to get precipitation to keep things green through the spring. Then things cure out and dry up, by May, and by the summer things are golden brown in the hills around here. And speaking of vegetation, there was an outbreak of wildfires this past weekend. There was a strong east wind event, and so any fire that did start was going to be able to spread quickly. I think this was still a bit of a surprise to see this type of fire in January after the big precipitation events that we got. So there's a lot of question on, are these lingering drought effects that was allowing some of this vegetation to burn so much? This one's near Big Sur, the Colorado fire, and so we still have to be thinking about the long-term drought effects on wildfire. And so I will wrap up. I think I've gone a couple minutes long, but with the summary slide here, and I'll just finish there and then take questions if you have time at the end. So thank you.
Great, thanks, Dan. As I transition over to Mike for the Outlook, there's one quick question. Someone was asking about 2011 and 2013, if they were La Niña years or not.
Yeah, 2011 was a strong La Niña year, and 2013 was an ENSO neutral year. So that is something to consider. We are in a La Niña year right now.
Okay, great. Thanks, Dan. And then Mike, I pass control over to you.
Great. I just went full screen. You can see the slides?
I still see the PowerPoint like in non-viewer mode.
Oh yeah, let me try to share the entire screen. I think I just shared PowerPoint.
Okay.
So, try it again. Okay,
there you
that's
go. You're good to go.
Great. All right, so great talk from Dan to get us started today. I will now focus a little bit more on the outlooks for the rest of the water year, but I also did want to start out with a couple of additional slides that will give us some context as to what we've observed so far for the water year to date. And I'll just point out that many of the tools that I'll be showing, or the forecast products that I'll be showing during the meeting today, you can access on the Center for Western Weather and Water Extremes website. So really happy to be here with everybody, and we can dive right in. So Dan gave some really great visual images of the current conditions and recent conditions that have been observed in our region in the West. And I wanted to just start out with a comparison of the Enterprise Bridge near Lake Oroville from October of 2015, so a previous very dry period in the state of California. And then just to give a little context as to where we are now, or where we were at the start of the water year, this is a similar aerial photograph from this past September. So as Dan emphasized in his talk, we really were starting the beginning of this water year with the dice having been loaded towards very dry conditions and multi-year drought conditions in our region. So a big hill to climb in terms of getting our way out of this and getting back to normal conditions or surplus conditions. So as I mentioned, I included a few slides here, which I think will complement Dan's talk really nicely and give a little bit more information as to where we are, sort of the water year to date perspective over our region. So a first element of this, which was alluded to in one of the questions that we just heard, we want to have an assessment as we look at where we've gotten so far and also looking at our forecast going forward as to what's going on remotely in the tropical Pacific with respect to the El Nino Southern Oscillation. So this is a cool plot from the IRI website, and this was created in collaboration with CPC. So you can see the y-axis here is the Niño 3-4 SST anomaly. So basically one measure of the state or the phase of the El Nino Southern Oscillation. And then the x-axis here at the bottom shows both an observed data point. So what was the observed standardized anomaly in the month of December? That's the black point here. And then a forecast, 3-month average forecast for this index going out into next fall. And there's a blend of dynamical models and statistical models that are plotted here. So I just want to point out, you can see, as we all know, as most of us know at this point, we're still in a moderate to strong La Niña phase in the tropics. I've included the latest 7-day averages for SST and SST anomalies on the CPC website here, just for reference. And the forecast is for these strong to moderate conditions to persist into late spring. And then we should be converging more towards ENSO neutral conditions as we get into late summer. So we'll keep an eye on how that forecast evolves. But this is obviously a key ingredient of the seasonal outlooks that I'll show later in the talk. So look, with this in mind, given that that's our observed El Nino Southern Oscillation conditions now in the tropics, let's just look a little bit more closely at what we've seen to date during the water year over our region. And again, as I mentioned, this should complement some of what Dan showed really nicely. So this is a plot that we update monthly on the CW3 website. So this is a total water year to date precipitation anomaly in the region expressed as a percentage. So it just compares how much precipitation each grid cell across the region has accumulated up to this point in the water year relative to normal conditions calculated over a 40-year period 30-year period in the historical record. So you can see, as we saw, sort of consistent with the plots that Dan showed, there's been a pretty significantly above normal precipitation accumulated over the Sierras and northern and central Nevada, and also above normal conditions that we've seen in the extreme Pacific Northwest, and then near normal or below normal conditions over parts of Southern California, but above normal near the LA basin, and then much lower than normal conditions observed in the desert Southwest. And I wanted to include an update of this as of this morning. So this anomaly plot was shown as of January 1st. This is a daily version of this plot, but it's actually showing the raw values of precipitation relative to normal rather than showing it as a percentage. But it's showing a similar qualitative picture. And the thing I wanted to point out here is that just in the first 3 weeks of January alone, we've seen, with these recent dry conditions in Southern California and the desert Southwest, that conditions that were running maybe at or slightly above normal for the water year to date relative to normal is now, we're now seeing, closer to normal or slightly below normal values in our region. So we've really kind of flattened out, as you could see in the Northern Sierra 8-station index plot that Dan showed, both in the Sierra regions, but also in the Southern California region due to the recent dry period to start the year. And this is another related tool which now shifts more into statistical prediction. This is another tool that we include on our website. It's now showing, instead of what we've observed for the water year to date, this is showing, as of the first of the month, the odds of the water year reaching 100% of normal precipitation. So again, normal is defined relative to a 30-year climatological baseline. This is a prediction that we update on the first of each month on our website. And it'll be really interesting to see what this shows next week as we ingest the January information from this year into the statistical model. But we can see that as of the 1st of January, it's very unlikely that the desert Southwest, Southern Nevada, and Southern California would reach their normal level of precipitation, whereas we got off to a really good start in Northern and Central California, and especially in the Sierra regions. So there's a high chance of the water year reaching normal precipitation in those regions. So look on our website for this updated forecast next week on the 1st of February. And then I had also included a plot of the Northern Sierra 8 station index, but I saw that Dan included this. So I wanted to also retain the Southern Sierra 5 station index, which was updated as of this morning. So just moving a little bit further south and seeing where we are in the cumulative precip function as as of January 24th. So this year is shown in the blue line, as was the case in Dan's plot for the Northern Sierras. And it's just worth noting here again, you see that flatlining of accumulated precipitation as we've entered into this dry period after starting out well above average in the Southern Sierras as well. And then there are these other extreme wet and extreme dry years that we can track, and that you can track as this updates on the, as we go through the rest of the water year. And one more way to look at this is a very similar concept, but shown in kind of a different display on the CW3E website. So what we update here daily using station gauge data across the region is the Western US water year-to-date cumulative precipitation expressed in deciles. So the bottom line here is that the greens are showing you station gauge data that are tracking well above normal with respect to climatology up to this point in the water year. And then the browns are showing you areas where we're seeing a below normal tracking for cumulative precip up to this point in the water year. So zooming in a bit on the California and Nevada region, we can see some, a couple of trends that emerge. The Southwest, and in particular Southern California and extending into Southern Nevada, have generally seen below normal tracking for cumulative precip to this point, whereas in the Sierras, we've seen obviously mostly above normal tracking. And just to show you what you can do, this is an interactive tool that's on our website. So let's say that we click on two of these dots, one at the Reno International Airport and another at the San Diego International Airport. This is what you will see appear on the website. So we get a sense of how previous years, shown in black lines, have tracked for each water year going back to 1937 in the case of the Reno Airport. And then the y-axis is just the cumulative precip total that's been observed. And this is then expressed as a percentile. So the red line is this water year, and we see that we're at the 95th percentile relative to all of the historical conditions for precip. So it's a historically wet year thus far at that particular gauge. And by comparison, we can look, in the southern part of the domain here in San Diego, and we're tracking below normal thus far. So the red line here with respect to the median value shown in green is demonstrating that we're kind of at below average conditions due to this recent dry period in the last 3 or 4 weeks. And we're currently sitting at the 33rd percentile relative to all years. So just wanted to raise awareness to this group that we have some of these supplemental tools on the CW3E website that can help you get a feel for where we're at in the current water year. And these are updated every day. Okay, so shifting more into additional forecasts, we looked at the odds of water year normal forecast, which again is kind of a historical statistical model just based on past conditions. And we also have some other tools that I wanted to raise your awareness of on our CW3 website. We first have looking more at the short-term S2S or subseasonal to seasonal range, we have some subseasonal atmospheric river activity outlooks that we update on our website. So I'll just show 3 of the dynamical models that we use to make these predictions here. The left plot is the NCEP forecast system, the middle plot is ECMWF, and the right plot is ECCC. And what we plot here, the top row, is the predicted number of days in the week 3 lead time period. In this case, that's February 4th to the 10th. The forecasted number of days with an atmospheric river predicted to occur. So we feed in the IVT data from each model and we run it through an atmospheric river detection algorithm. And we just say, how many days during week 3 do we expect atmospheric river activity? We do that for each model. The middle row shows the climatology for each model. Climatology for each model during this period in past forecasts. And then the real take home here is the bottom row, which is the difference between the top forecast and the middle hindcast climatology. So we get a forecast anomaly for atmospheric river occurrence. The blues here in the bottom row indicate above normal chance of AR activity, and the reds and oranges indicate below normal. And the point I wanted to make here, if you compare the forecasts for week 3 upcoming for all 3 models, there's a lot of uncertainty right now in what the dynamical ensembles are predicting. ECMWF is locked into a below normal, kind of continuing the dry pattern that we've seen in our region. Whereas, for example, the NCEP model is favoring maybe some undercutting and above normal chances for AR activity in our region. So many of these models were locking into dry conditions in the early part of January, but we're seeing a lot more uncertainty across the models for the coming weeks. So we'll need to stay tuned to this. And then I'll just finish up with our seasonal forecast. So looking more long range, we have 2 seasonal outlooks that are updated monthly on the CW3 website. The first one here is based on canonical correlation analysis. This is the latest one that we have for JFM. And the predictor that goes into the statistical model are SST patterns in the Pacific. So we look at historical relationships between Pacific Basin SST anomalies and subsequent precipitation over the Western US region for the next 3 months. And the skill assessment is provided in Gershenov et al. 2003, so you can go back and look to see how this statistical model has done historically. The take home here is that this particular model is predicting persistent dry conditions relative to normal over the Southwest and over Southern California, and above normal precipitation conditions for the Pacific Northwest. And we start to get into more of an uncertainty for the sign in Central California and Nevada. We also update at the beginning of each month another statistical model, which is based on machine learning methods. So the underlying methodology for this can be found in Gibson et al. 2021. And what we do here is we train a number of machine learning models based on different predictor fields from the previous month. So we use SST, but we also use things like velocity potential over the Pacific Basin, other SST modes that are outside of the tropics. And we come up with a prediction that tells you what the most likely pattern for precip anomalies for JFM will be. And in this case, you can see we've highlighted here pattern 4 is the most probable pattern from the machine learning models that we see. And it's consistent with the CCA outlook that we showed on the left. Basically, higher chance of a dry southwest and also higher chance of a wet northwest relative to normal conditions. We also include the NMME forecasts here on the bottom row, so we can get a comparison between what this machine learning based method is telling us with what the NMME ensemble data is telling us as well. And in this case, there's a lot of consistency in this sort of canonical La Niña dipole pattern of wet northwest, dry southwest continuing through JFM. And so far, it seems like, especially for the southwest, that is bared out for January. And then one last slide here for comparison is the CPC JFM Outlook, which was issued on December 16th and is available on the CPC website. And again, generally qualitatively similar. in terms of the sign of the anomalies that are predicted for our region, although some important differences in the chances of above or below normal for Northern California and Nevada. So I just have some summary bullet points here that I can leave up, and I think that will be all for me. Thank you very much.
Thanks, Mike. One quick question I'm going to throw out here before we move on to Mike and Steph, and this is one that came in sort of in between the two presentations, so I think you or Dan could address it. I think you guys have been sharing a lot about this year, but the question was how much rain is required to bridge the deficit of the multi-year drought, so like the 3-year drought, if you guys have a sense of to share.
That's a great question. Dan, I would defer to you on this. You may have a better feel for this than me.
Yeah, I do not have those numbers in front of me at the moment. I'll just say the deficit of precipitation has accumulated quite a lot over the previous 2 years. And like I said, it would take, I think, a well above average water year to get close to getting, alleviating that deficit. But yeah, unfortunately, I don't have those numbers in front of me, but we could, I could dig into those and share them with you after, Amanda, so they could be perhaps shared in the write-up of this at some point.
This is Mike Anderson. Hi, everybody. We
Hi,
actually
go ahead.
Worked with our partners at the USGS to run the basin characterization model, and basically took increments of 10% above average precipitation conditions and ran it through the model until we got average runoff out of the model, given the conditions that were present in October of 2021. And the magic number came out to be 140%. After we got through December, we were sitting well above average and had that fantastic AR. So through the first quarter of the water year in the books, we reran it again to say, well, what would we need from there on out? And the answer came out to be about average. If we could maintain an average pace, we could probably get average runoff. Well, we didn't do that. So we're going to be working with them. I actually meet with them later today to talk about kind of some scenario simulations to try and tease this out and try and tease out where we might be as we hit the halfway point in the water year, right around that April 1, where we pivot from the wet season to the dry season and snowmelt. So
hi, and this is Steph McAfee, the Nevada State climatologist, and just to give you a little perspective, at least in northern Nevada, in southern Nevada, of course, it gets more complicated with the monsoon. If we were to look at someplace like the Reno airport and do a retrospective back to the start of the 2020 water year, we're roughly, about 4 inches of precip short. This would be actually a little more than half a year's precip short over 3 years. So that's sort of how big the deficit would be to make up. Now, granted, in the October storm, Reno got over half a year's precipitation in a couple of days. So a couple of good storms could be enough to get us to normal, at least in terms of precipitation. Of course, the cascading impacts in other systems outside of reservoirs and water supply gets more complicated.
Thanks, Steph and Mike. With that, it seems like a good transition over to you guys, since you guys are starting to get into what we asked you to talk about. Steph, do you want to go ahead and add more? What you just shared was great, but if there's anything else you'd like to share and give your perspective on?
Sure. I guess I was thinking over the last couple of days about what sort of perspective I had on this drought at this point. And so I guess from a big picture perspective, I am expecting that drought will be continuing at least into the summer in southern Nevada. And that will be, how long that continues after that will be contingent on the monsoon. Northern Nevada is a little less clear. Obviously, we're in much better shape than we've been in the last couple of years, but I think as Dan really nicely laid out, we're at a point where we could have a year like 2013. We're at a point where we could have a year like 2011. And whether we sort of persist in this slight long-term drought situation is really dependent on what happens during the rest of the winter. And when we're thinking about the longer-term conditions, one of the things that I'm really thinking about is trying to get a better handle on impacts. After the last drought, 2012 to 2015, we saw some places in the state that seemed to have really persistent ecosystem impacts from that drought. And so I'm thinking about, well, what would the legacy of this drought be? Even if we do have a good rest of the winter, or maybe some spring rains, what is this going to look like longer term? And this is kind of in line with some recent sort of political acknowledgement of drought in the state of Nevada as well. I think many of you may have seen the recent proclamation by Nevada's governor noting that we're moving into sort of something of a new world, where what we used to think about as drought may be reflective of broader term changes. You may not have noticed this proclamation. It came out sort of during that first December storm. It was perhaps not the very best of timing, but yeah, the question for me in Nevada is starting to be less what is going on with this particular drought and what can we learn from this particular drought for the next drought. And sorry, that was a bit disorganized, but that is actually how my brain is working around drought these days.
No, that's great, Steph. Especially the way you ended there is learning for the next drought and some of the things we've all been thinking about, I think, going here. Mike, did you want to offer a perspective from you over on the California side about what's been going on some more and concerns, thoughts going ahead? Mike, are you still there? Did I lose?
Yeah, sorry, double mute.
There it goes.
So anyways, what I was saying, and my cat was really enjoying, was I thought Dan laid out a really nice perspective on the water year so far. And kind of the on again, off again nature of it. And there are some elements in it, though, that are worth highlighting. He noted that last year was the second driest year in our period of record, beating, coming very close to 1924. And 1924 is a long time ago, but still stands out as the driest single year on record. Now, when we pair it with 2020, guess what happens? We actually do set a record. The 2-year record was 76-77, very extreme drought that actually is within living memory of a lot of folks. And turns out we beat that one, but there's a significant difference in the two droughts in that this one is about 3 degrees Fahrenheit warmer in terms of the average temperature. So we're doing drier conditions, but doing them warmer. And really kind of interesting. Now we look at then how we got into this year, and Dan had mentioned record snowfall in December at the Central Sierra Snow Lab. In October, we had single-day record precipitation for Sacramento, many places in Northern California with that fantastic atmospheric river that came through. And then we have these periods, very wet, long dry, wet, dry. And we are at this kind of pivot point of, do we go 2013 where it stays dry, or do we kind of move out of this midwinter dry spell into a wet period again? And if you look at the models, you see uncertainty, as Mike DeFlorio had mentioned. There are hints that that high pressure might move out beginning of February, we see a little cutoff low work its way down the coast, get us a little precipitation, at least on this side of the Sierra. A lot of that depends on the trajectory that low pressure takes, how far south it digs, and how much moisture it can entrain in there. And then what happens next? Does the high pressure stay to the west, leaving that storm door open, or does it reform in the eastern Pacific, effectively cutting us off from the rain? We're still working on getting better at predicting those outcomes. Do enjoy working with the research community to kind of do that, because as the world continues to warm and we see new ways that drought is expressing itself, and as Stefan mentioned, really trying to understand better what the longer term implications are, because boy, this is already significant drought number 3 of the 21st century. We aren't even a quarter of the way into the century yet. So a lot of interesting things to dig into, and this is a good group to work with in that regard. Thank you all for your attention. Happy to answer any questions.
Thanks, Mike. One came in, and I'm not. I'll leave it up to you whether you want to answer this one or not. Someone was asking, in 76, 77, we were looking at dramatic cutbacks. This year's been pretty mellow. For example, 15% cutback. How do you explain that?
Sure. So in 76, 77, again, in that second year of drought, extreme drought, as they got into it, reservoir levels dropped to lower levels. They had to cut back on that. We saw that actually happen last year as we got into spring, and the expected snowpack did not produce the runoff that we thought it was going to, leading to the temporary urgency change permits of the major water projects. We have seen since 76, 77 a really significant investment, especially after the 86 to 92 drought and the 2 recent droughts that we've been through, in really developing resilience to these dry conditions. And so we're seeing some of that benefit come in play. But this year we get the benefit of those extreme wets that we've had in the first quarter of the water year, which offset to a degree the extreme drought that was experienced up through the last water year and heading into this one. And so I think Dan had mentioned, things are improved, but we're not out of drought, and that'll probably be the story of this year.
Great, thanks, Mike. At this time, I've got 2 questions for other Mike and Dan. So at this time, I want to say, Mike or Steph, do you want to add anything last here before I move on to some of these other questions for the first speakers? All right, Dan, so well, for the folks that are on the phone, I'm just going to move into here the questions while we're here at the end. I think we've hit a lot of the ones we've gotten along the way here by other speakers or other questions and things like that. But for Dan, this is an interesting question, and I think it's asking, if we get a real wet late winter like 2011, would that tend to make a dent on reducing drought? So I thought it was an interesting question, because we think about whether we get some of the wetness early on versus later. There might be some interesting answers here, or your thoughts.
Yeah, that's a good question. The timing is definitely important. We saw last year was dry to begin with, but then it was extremely dry in April and warm, and so that accelerated the already small snowpack to melt even quicker. And so, you know, in 2011, for example, from mid-February through late March, you know, I wouldn't necessarily expect that big of a year again, because that March was huge. But if we do get consistent precipitation and snowpack from, let's say, you know, February through March, that should probably bring us back above normal snowpack again, depending on, you know, where the storms come in and that sort of thing. But let's just say the Sierra does pick back up in pace. You yeah, I think it would all depend then on what happens in the spring with both precipitation and also temperatures and evaporative demand, and how quickly or how long the snow stays on the mountains. We really don't want the snow to melt early like it did last year, and so this gets back also to the soil moisture. Since it's already got that saturation, we're hoping that that will mean more of the runoff in the spring will go into the streams and reservoirs instead of just going to saturate that soil. And so, this will all lead to seeing, how those reservoirs that are below normal begin to refill in the spring. And so you really won't have a very good sense of that until, after our snowpack peaks and we get into seeing what the spring conditions are. But if it does pick back up, there's a good chance we could have continued improvements. Like we said, those long dry spells are long to get through, but they are fairly common in the Sierra.
Great, thanks, Dan. And then our final question goes over to Mike DeFlorio. I think this is a little bit of a technical one, but they ask, NOAA CPC does not project a wetter than usual Northern California and Nevada region. Does the machine learning have more of an AR component to explain the difference between the projected wetter than usual JFM compared to CPC?
Yeah, that's a great question. What I would emphasize in considering the CPC outlooks and then also the machine learning outlooks and the CW3 CCA outlooks is that there are a variety of different input predictor fields that go into those models. So while they're all making a prediction for the same forecast period and for the same predictand, which is precip anomalies, the input that's going into those models will be different. There will be some commonalities. For example, SST anomalies in the Pacific are shared components of the inputs that go into making those predictions, but the other predictor variables will differ, and also the way that the statistical models are trained will differ. So it's a little bit of not an apples to apples thing, and you do see differences in the resultant predictions, and being able to trace back why that's the case can actually be difficult because the model construction and configuration can be so different. But it's a really good question, and you'd have to do a deep dive on the individual model predictor fields in making previous predictions to see which areas over the Western US are most sensitive to changes in the input fields.
Great, thanks, Mike. And if you want to follow up with that person who asked the question, I can pass along their info, or the person who asked the question you want to follow up with Mike, let me know. My email's up here on the screen. And if anyone else has any questions that didn't get answered today or questions you come up with later, feel free to reach out to me and I can reach out to the speakers. With that, I just want to say thanks everyone for joining us today, and thank you guys for all our great speakers. At this time, I just want to mention that, re-mention that the recording with a brief summary of this webinar will be available on drought.gov later, as well as on the NIDIS YouTube channel. Our next webinar is scheduled for Monday, March 28th. And around mid-February, also keep an eye out for the California-Nevada drought status update and a Western snow drought status update. We produce those on drought.gov in text form. And with that, I'll go ahead and close the webinar and say thanks everyone for joining today. We do have a post-webinar survey if you'd like to fill it out and give us tips, feedback, things you'd like to see in future webinars. We always read those, so thank you to those who fill those out. And if anyone wants to fill it out this time, that'd be great. Otherwise, I'll go ahead and close the webinar and say thanks everyone for joining us today, and I hope you have a great day.
Take care, everyone.
Thank you.